Hello and welcome again as we look at yet another multiple choice question for IB chemistry. This one says, which of these statements are correct? Zinc is not the transition element. That in fact is a correct statement. It's straight out of section 13 of the IB chemistry guide, where it says that transition elements need to have unpaired electrons. Now in that periodic table that you get in paper 1, it would say that zinc is 30, and what that means is that its electronic configuration is argon core 4s2 3d10. All of the d orbitals are full with electrons in opposite spins, 5 one way and 5 the other way. So with this full d subshell, it means that even if there's d orbital splitting as a result of a complex, that complex would not have any color because there won't be any opportunities for transitions of electrons from lower levels to higher levels. So zinc is not a transition element because it has a full d subshell. Second statement is manganese 2 bromide is paramagnetic, and again we need to go into section 13 of the IB chemistry guide, and you would see it says that the presence of unpaired electrons in these transition elements gives rise to paramagnetism, or this magnetic property. And manganese, according to our periodic table, is 25. So its electron configuration is argon core 4s2 3d5. That's manganese, and when it forms Mn2 positive as part of manganese bromide, what's lost are these 4s2 electrons, leaving you with 5 unpaired electrons, all with their spin in the same direction here in this d subshell, making it, of course, a very good case for paramagnetism because of these unpaired electrons. And our final statement here is that all Lewis bases are ligands. Well, a good way to get away from all of the confusion about Lewis bases, Bronsted-Lowry bases, ligands, and even electrophiles is to have one molecule as your base for all of that. And that base is NH3, ammonia. Very important molecule to study about in any chemistry. It's got a lone pair here. This lone pair of electrons can accept an H plus ion. When it does that, ammonia behaves as a Bronsted-Lowry base. But when ammonia donates this lone pair to another species, like BF3 for example, to form BFNH3, when it does that, it's behaving as a Lewis base. So ammonia can behave as a Lewis base. But ligands also, when they form complexes with transition metal elements like manganese, these ligands need to have lone pairs to donate to these transition metal ions. So ligands and Lewis bases both need lone pairs to donate. And while we're at it, we should note that the word nucleophile also applies to ammonia, and in fact all Lewis bases can function as ligands, and they are also nucleophiles. A nucleophile needs to have a lone pair like ammonia does, so that it can then be drawn towards a positive center in the process of a nucleophilic reaction, which is covered in topic 20, organic chemistry. A nucleophile, a Lewis base, and a ligand can all be the same thing, and ammonia is a very good example of that. It so happens that ammonia is also a Bronsted-Lowry base, and of course the answer to this question is D.